All right, join me in your science book on page 218. If you don't have your science book out, pause the video now and get it out so you're ready to follow along. What you're seeing on the screen here is the electromagnetic spectrum. These are all the different waves that we are aware of and know about, and the wavelengths of these different rays. And you'll notice within the electromagnetic spectrum there's a small number of these waves that we can see, and we see them as color. Okay. So let's start on the top of page 218. Follow along. What is the electromagnetic spectrum? The sun's energy is carried to Earth by electromagnetic waves. The electromagnetic spectrum is the wide range of electromagnetic radiation ordered by wavelength. So that's what you're looking at here. It's in the order by how long the wavelengths are. Okay, longer wavelengths obviously over here to the left, shorter wavelengths to the right. A wavelength is the distance along a wave before it repeats. Shorter wavelengths have higher energy, while longer wavelengths have lower energy. So low energy wavelengths are to the left, higher energy wavelengths on this spectrum are to the right. The electromagnetic spectrum, arranged from waves with the lowest amount of energy to waves with the highest amount of energy, consists of radio waves, microwaves, infrared rays, visible light, which we see right here, ultraviolet light, X-rays, and gamma rays. Radio waves have the longest wavelengths and include transmissions of AM radio, shortwave radio, TV, and FM radio. Microwaves used to power radar and satellite systems, as well as ovens that cook food quickly, are in the next part of the spectrum. Infrared rays, which people feel as heat, are given off by the sun and other sources such as active volcanoes. Some restaurants use infrared lamps to keep food warm. In the middle of the spectrum, and now I'm on page 219 by the way, in the middle of the spectrum are the wavelengths of visible light. We see these wavelengths as colors that range from red to violet. The next part of the spectrum includes ultraviolet light waves. Ultraviolet waves carry more energy than visible light waves. Overexposure to ultraviolet rays and other high-energy waves can be harmful to humans. After ultraviolet rays are X-rays and gamma rays. Gamma rays have very short wavelengths and carry so much energy that they can even pass through metals and concrete. Okay, turning the page onto page 220. How does electromagnetic radiation reach Earth? Electromagnetic waves travel about 150 million kilometers, or 93 million miles, to reach Earth from the sun. There is no air in the empty space between Earth's atmosphere and the sun. Without air, there is no substance for waves to travel through. How do electromagnetic waves reach Earth? The answer is they travel by radiation. Radiation is the transfer of energy by electromagnetic waves. The energy given off by the sun is called radiant energy. It does not require two objects to be touching, as conduction does, nor does it require that the objects be joined by a liquid or a gas, as convection does. The light produced by the sun is the most common example of radiation, but all objects give off a wide range of electromagnetic waves. The strength of each type of radiation depends on the temperature of the object. Absorption and emission of radiant energy. When radiant energy falls on an object, part of it is reflected and part of it is absorbed. Absorption is the process of taking in radiant energy. A perfect absorber of electromagnetic radiation appears black, because it absorbs all colors of visible light as well as other types of radiation. Objects that appear dark absorb some electromagnetic radiation, while objects that appear white or light-colored reflect more radiation than they absorb. That is why the jar you wrapped in black paper in the Explore activity heated the water to a higher temperature. We didn't do that activity, but you all know that during the summer, the black street is hotter than the sidewalk, right? Because the black street is going to absorb more of that heat energy. You might notice that dark objects absorb more radiant energy if, on a hot day, you touch a black metal surface such as a car. The surface will feel hotter than a white metal surface. It has absorbed more infrared radiation, which people feel as heat energy. Okay, join me on page 221. Emission is the process of giving off absorbed electromagnetic waves. A good absorber is also a good emitter. Therefore, a black metal object takes in more electromagnetic radiation, but it also emits more. This means that once a dark object is away from the source of radiation, it will cool off faster than a similar light-colored object. Solar radiation is the electromagnetic radiation emitted by the sun. With a surface temperature of about 5,500 degrees Celsius to 6,000 degrees Celsius, or 9,900 degrees Fahrenheit to 11,000 degrees Fahrenheit, the sun emits a great amount of high-energy, short-wavelength radiation. Most of it lies in the visible and near-visible or infrared parts of the electromagnetic spectrum. A small percentage falls in the ultraviolet range of the spectrum. As the sun's incoming energy passes through Earth's atmosphere, it may be absorbed, reflected, or scattered. Air molecules, water vapor, clouds, dust, and pollutants play a role in this process. Wavelengths of visible light are not greatly absorbed by anything in the atmosphere, so they are able to reach Earth's surface. Each visible color has its own properties and scatters differently. For example, blue light, which has a shorter wavelength, is scattered more easily than red or yellow light. This is why the sky looks blue and the sun looks yellow. All right, thanks for following along. You may continue now in your Google Classroom answering the questions. Thanks for watching, and I'll see you on the next one.